Hi again, this is the second of the two talks on probability. It's much shorter than the previous one. So for the first one, we just looked at basic concepts of probability and I defined what a probability was and different ways of defining it and estimating it. And then we moved on from that. We looked at the idea of a conditional probability, a marginal probability, a joint probability. And all of that was ultimately so as to use in the context of diagnostic testing, where we then went into sensitivity and specificity and positive predictive and negative predictive, and also just the prevalence of the particular condition. Now, what I want to do now is look at a situation where rather than having a table that's completely filled out, I give you the sensitivity and I give you the specificity and I tell you how prevalent the condition was, and that's it. And then based on that information, you want to work out what's the positive predictive value, which is to say, if you test positive, how likely is it you have the condition? And the negative predictive, which is to say, if you test negative, how likely is it that you don't have the condition? So we're coming back to screening tests, to diagnostics, and we're looking at a test that's 95% accurate for those who do have cancer and 90% accurate for those who do not have cancer. And in terms of the prevalence, we're told that the proportion of people in the population is 0.005, in other words, 5 in 1,000. And then the kind of questions we want to answer is that if we know an individual has been diagnosed as having cancer, what is the probability that he or she actually has cancer? And we'd also like to know the flip side of that, which is to say, if an individual has been diagnosed as not having cancer, how likely is it that he or she doesn't have cancer? So this is the way we're going to go about it. We're going to start from a blank table. It's like the ones that you've seen earlier, except now, as I say, you start off from the blank. And what I want you to do is basically to start off with this table yourself and try and fill it in as we go along. So what we have here on the columns is we have the actual, that is to say, whether somebody has cancer or they don't have cancer. And this cancer in quotes here is their diagnosis. So this is a diagnosis of cancer, DC, and DNC is a diagnosis of no cancer. So the first thing we want to do is we want to populate the table, which is to say we want to basically fill in the table. So what I want you to do is to stop the video now, have the table at the ready, and we'll then go forward. So this is where I want you to start from. Start from an assumption that in total we have 100,000. So we're going to take it that the total number of people, these are totals down here. So this is the total number of people. We're imagining that we have 100,000 people in our population. Then ask yourself, if you had 100,000, how many would you expect to actually have cancer in here? How many would you expect not to have cancer? Of the ones who have cancer, how many would you expect to have a positive diagnosis, as in a diagnosis of cancer? Similarly, for the ones who don't have cancer, how many do you think will have a positive or a negative diagnosis? And if you can work all of those out, this will allow you to fill out this information here. So try doing that first. And then when you've made an attempt at that, we'll go through the solution. So pause video. Now coming back again, here we go. So we know the prevalence is 0.005. So the first thing we can do is we can say, well, we have 10,000 people. Sorry, that actually should say 100,000 people. We have 100,000 people. We have a prevalence of 5 in 1,000. And that means we'd expect to have 500 people who actually have cancer. And because we have 500 with cancer and we have 100,000, which is now correct, people in total, if we simply subtract 500 from 100,000, we'll get 99,500. So we now know how many people have cancer, and we now know how many people don't have cancer. We're now going to use the sensitivity. So we were told that this test was accurate for 95% of people who do have cancer. That means it has a sensitivity of 95%. And if it's got a sensitivity of 95%, and you know you have 500 people, well, if you take 500 and you multiply it by the sensitivity, then you should get the number of people who will end up with a positive diagnosis. So if we do that, this is what you get. You get 475, which is the number down here, 500, multiplied by the sensitivity, which was 0.95. And then we're going to do the same thing with the specificity. So the specificity was 0.9. The total number of people who don't have cancer is 99,500. The specificity is saying if you don't have cancer, how likely is it that you come up negative, or as in negative diagnosis? So that's your total number down here, 99,500, multiplied by the specificity up here, and that gives you this number here. And then the next thing you want to do is ultimately to fill in a table. So from here on, it's just addition and subtraction. So we know we have 475 here. We know where we have a total of 500. So we can subtract one from the other, and that will tell us that we have 25 people here. We can do something similar here. We can subtract 89,550 from 99,500, and that will allow us to fill in the blanks. And then finally, if we simply sum across here, we can say, well, look, the number of people with a diagnosis of cancer was 475 plus 9,950, and that will give us this total. And the number of people diagnosed as not having cancer will be 25 plus 89,550, and that will give us the number over here. And that ultimately gives you a complete table, so it now should look like what we did in part 1 of this lecture. So now we want to know what's the positive predictive value and the negative predictive value. And keep in mind the information we use to actually put this table together. We use the prevalence to get us this number. We use the sensitivity to get this number. And we use the specificity to get this number. And we now want to know what's the positive predictive value and the negative predictive value. And keep in mind both of those are conditional probabilities. And the positive predictive value is looking at people who test positive, and the negative predictive value is looking at the people who test negative. So everybody on this row here has a diagnosis of cancer. That's your so-called positive diagnosis. And everybody in here has a diagnosis of not having cancer. So then the probability of having a positive diagnosis is simply the number of people who test positive, which is 10425 out of 100,000. So we would expect that about 10% of people are going to test positive. And keep in mind that the actual condition is such that only 5 in 1,000 people have it. So there's an awful lot more people testing positive than there are people with the condition. And that highlights the problem of false positives. Now the positive predictive value is saying, how likely is it you have cancer if you have a positive diagnosis? So we're interested in this group here. In the notation that we had way back, this would be like your capital N. And this number here would be like your small m. So the chances you have cancer, you actually have cancer, if you have a positive diagnosis, is 475 out of 10,425. So that's 0.0456. So 0.0456 is clearly a small number, but again, keep in mind that the chances of having cancer originally was only 5 in 1,000. And then the negative predictive value is saying what's the chances that you don't have cancer if you have a negative diagnosis. And using the same logic that we had before, this will give you what you have here. So we're looking at the number of people who have a negative diagnosis divided by, the number of people with a negative diagnosis is this number over here somewhere. And the number of people of that who don't have cancer is 89550. And that gives you this. And again, that's extremely close to 1. But again, at the beginning, we only have 5 in 1,000 who actually have the condition. So by filling out the table using the sensitivity and the specificity and the prevalence, we've managed to calculate both the positive predictive value and the negative predictive value. This one here is a very, very useful link. It's linking to this particular book here, Medical Statistics at a Glance, it's a very nice book, but it covers everything in about 2 pages. So it's a bit short if you're using it for a textbook, but it has some really nice online MCQs. And if you go here and then specify you want to go to chapter 38, I think the link will bring you directly there anyway. Then it'll have interactive MCQs, which is to say it has MCQs relating to contingency tables, and it'll actually give you the solutions along with the questions. So well worth looking at that. So in summary then, I've looked at contingency tables. That's just those made up tables that you populate so as to calculate terms. We previously defined marginal, joint, and conditional, and then using that, we calculated and we defined sensitivity, specificity, positive predictive, and negative predictive value. Now, what's left to cover and which is not part of this presentation is the normal distribution, and you'll see that in the notes, and there'll be links to various videos that go with that. And then once all of this is over, we're going to be moving on to Stata, as no doubt you'll be delighted to hear.